This was some weirdness from AI.
Hello YouTube. This video is a bit different. I'm currently working on a longer video about spider silk, which it turns out is way more complicated than I thought, and it's taking me a long time to write, so that's why I haven't put anything up here in a while. But crazy things sometimes happen in the research for these videos, and I really wanted to share this one because it's kind of wild. This was something I'd heard of happening, but to see it with my own eyes was something else. And if you like sciencing, you'll want to know about this. Regular viewers will know that in the past I've been pretty critical of AI-generated stuff. The truth is, I think there are bad uses and good uses of AI. I very much dislike that generative AI has ripped off the work of artists all the world over. I'm deeply uncomfortable with the fact that it's making hiring decisions for many companies. And no, when I'm having a warranty issue with my camel jousting lance, I do not want to talk to your stupid virtual assistant. But AI does a great job of analyzing data and recognizing patterns. AlphaFold 3, a software tool used for analyzing proteins, is largely AI-driven, and it's resulted in some pretty major discoveries in the spider science world. So AI can have really legitimate, useful applications. One of them, for someone like me, could be research, in a particular way. In the videos I make about spiders, I'm always careful to ensure that the information I'm sharing is as correct as possible. So that means that when I say something, I usually point not just to someone else who said it, but to the people who actually observed it, measured it, did the experiments, fooled around and found out in the lab. That's the primary source. It's not enough to tell you just what we know about spiders. I want to be able to tell you how we know it. So much of my process in making videos involves a lot of scouring Google Scholar, tracking down academic papers, following chains of citations, screaming into pillows. And recently I've been thinking, could a robot do that? Google Scholar is great when you know which paper you're looking for. But when you're looking for the answer to one very particular question, it can take hours of searching and way too much coffee to find that one paper where someone actually measured what you're asking about. And today, I had a very particular question. I wanted to know how many silk spigots there were on the anterior spinnerets of a cross orb weaver. So I needed to find a record of somebody actually looking at them and counting, because my equipment isn't good enough for me to do that myself. There are a million papers on spinnerets, but only so many that actually answer that exact question. So I thought, let's give this job to an AI and see what happens. After all, a computer can read 500 papers in the time it takes me to read the title of one. So I gave it a shot, in this case with Google's Gemini. Now, in Gemini's defense, it's not exactly the best tool for this. There are other AI tools like Undermind and Consensus that are purpose-built for research, but most people aren't using those. And the way Gemini dealt with this scenario is troubling. First, I asked the question on its own. How many spigots are on the anterior spinnerets of Irenaeus diadematus? Gemini thought about this for a minute, and I had it in thinking mode, which is supposed to be geared towards solving complex problems, whatever that means. And it returned an answer. It said that there were around 62 spigots on each of the two anterior spinnerets, only one of which was a major ampulate spigot. If you're here and you're not a spider nerd, don't worry about what that means. The actual question isn't the point here. In its answer, Gemini behaved like a regular chatbot. It treated this as a conversation, and it didn't cite any sources for what it came up with, which was obviously useless to me. I clearly needed to be more specific about my expectations. Being a father of two, that was familiar territory, so I took a sterner tone. Find an academic paper that states that the anterior spinnerets of Irenaeus diadematus contain only one major ampulate spigot, and no Minecraft time till you're done. Again, it thought for 30 or 40 seconds. It seemed like it was doing a really thorough job. Then it came back with this. Key academic papers that establish and discuss this specific morphology include Moon and Tillinghast, 1996, The Spigots and Silk Glands of the Spider Araneus diadematus, Araneae araneidae, in the Journal of Arachnology, Volume 24, Issue 2, pages 108 to 120. This looks perfect. In my research so far, I've come across the names Moon and Tillinghast quite a bit. I know they're researchers in this field, and the Journal of Arachnology is the journal of the American Arachnological Society. I get a ton of papers out of that journal. Okay, great. That was pretty easy. It probably would have taken me a lot longer than that to find a paper that discussed this exact question using just Google Scholar. And this part's interesting. This is the primary modern reference for the spigot morphology of this species. It details the scanning electron microscopy findings that confirm each ALS possesses one functional major ampulate spigot, etc., etc. So not only did Gemini find the paper for me, it told me that this was the paper most others refer to on this question, and it summarized how the paper got to this conclusion. Amazing. Exactly what I need. Let's go grab that paper then. The way I normally go about this is to just copy and paste the title of the paper and throw that at Google Scholar. As I said, once you have a title, Google Scholar is fantastic. So that's what I did. One would think that it would be the first paper to come up with a title that specific. And yet it's not only not at the top, it's not here at all. Weird. Fortunately, Gemini provided the reference like an actual citation, so it might have been possible to dig the paper up manually. The citation is from 1996, in the Journal of Arachnology, Volume 24, Issue 2. The great thing about the Journal of Arachnology is that the entire thing is provided online for free, so I went to the website, clicked on all volumes, and just scrolled down to 1996. And there it is, the 3 issues from 1996, also known as Volume 24 as the citation specified. Click on Issue 2, and... As Isaac Asimov is often quoted as saying, the most exciting phrase to hear in science, the one that heralds new discoveries, is not, Eureka, I found it, but, that's funny. It's not here. Pages 108 to 120 are occupied by 2 other papers. There is no paper, either by those authors or by that title, or even about that subject, in this issue of the JOA. I checked the other 2 issues from that year. Nothing. Moon and Tillinghast hadn't published anything in that journal in 1996. I went back to Google Scholar and tried searching various things. Moon and Tillinghast 1996, I tried Moon and Tillinghast spinneret morphology, I ran the title on Sci-Hub. Nothing. Anywhere. This paper does not exist. Gemini made it up. And not only did it make up a citation, it actually claimed that it was the primary modern reference for this fact. Oh, Gemini, you mismatched cash piano. And this isn't just a matter of, oh, you just couldn't find the paper. I had literally gone to exactly where Gemini said I would find it. A real journal with real volume and issue numbers, and not only was it not there, something else entirely was there. It also wasn't a matter of, oh, it just gave the wrong citation for that particular fact. The citation itself is impossible, as it cites a particular issue and volume of a particular journal, which I checked, and found nothing but a deafeningly conspicuous lack of said paper. This was pretty concerning to me, because to be honest, had I not checked, I would have believed this. Gemini didn't just come up with a fabricated citation. It came up with a very, very believable one. M.J. Moon and E.K. Tillinghast are real researchers in this field. The Journal of Arachnology is a real and well-known journal in the field. The year matches the volume number correctly. Even the page range is correct. Gemini's citation says it's in issue number 2, pages 108 to 120, and the real issue number 2 covers pages 80 to 172. So Gemini's made-up page range falls within that. Every detail of this is believable, but the paper doesn't exist. So, is AI useful in digging up sources? It can be, but again, like a parent, you really have to check its homework to see if it did it right or just pretended to. In my earlier experiments with Gemini, I often found that the papers it linked to as sources didn't actually talk about what the AI said they talked about. Now, after a bit of digging on Google Scholar, I did find a paper that answered my question. Coddington 1989, which incidentally is a real paper in the Journal of Arachnology, but in volume 17. And it turns out that Gemini's actual answer was in fact basically correct. The anterior spinnerets contain only one major ampulate spigot. So, at least in this case, the overall answer the AI arrived at was right. But there are a ton of cases where AI has been outright wrong, and the fact that it can flat out make up citations, and very convincing ones, should have all of us checking receipts more carefully than maybe we have in the past. Nobody's right all the time, but if we can learn to be critical of what the robots are telling us, we might just be a little less wronger. And less wronger is more better. So that's been my experience using AI for research. Possibly helpful, but not exactly trustworthy. Maybe this might help some of you, either in your own research or in challenging questionable information and where your least favorite uncle got it from. A big thank you to my wife for improving this video, and a big thank you to my patrons who really keep this channel going. If you want to support this channel, that's the best way to do it. There's other research notes there, random spider interactions, and other exclusive content. And if you like the central driving principle of this channel, head over to my Shopify store for some channel merch. These are applicable in virtually every situation. These, on the other hand, make very little sense in almost all situations unless you've seen some of my other videos. Of course, just watching, liking, and sharing this video supports me and my work, so to all of you viewers, thank you so much for watching. I hope you've learned something about researching spiders using AI, and I hope to see you next time. Cheers!